Good evening. Welcome to the BS and Beer Show. BS, of course, stands for Building Science. Tonight's topic is building monitoring. Show me the data, or data, depending on your preference. I am Travis Brungard. I am so terribly late tonight that I've only got water, but once the presentation starts, I will be drinking again. God knows I need it. BS and Beer is an independent grassroots movement to share building science knowledge through local meetup groups and this, our Zoom show. The Brew Crew and our guests volunteer our time each week to bring you what we hope is a fun and informative discussion. I just want to take a second to thank Green Building Advisor and Fine Home Building Magazine, our media partners, and of course to thank our wonderful audience who shows up every week to enjoy this with us. Rather than go into our agenda, I'll kick it off to Kylie, who's going to start our announcements.
Yep. Hi, Travis. Hi, everybody. Thank you. I'm Kylie Jacques. I'm the senior editor at Green Building Advisor. I'm drinking Gerolsteiner sparkling mineral water. If you want to engage in the chat box, be sure to click on all panelists and attendees so everybody can see your comments. Every week, Fine Home Building sends out Zoom reminders about the show. And if you'd like to receive those, as well as additional information, join our mailing list at the bsandbeershow.com. The video recording of tonight's show will be available at Green Building Advisor. Past shows can be found on YouTube, and an audio-only version is now available on Spotify and Apple Podcasts. There's one event I'm going to highlight tonight, and then I will also add to the chat box a bunch of links to other events, as well as some recommendations for podcasts we think you might like. The event that I'd like to highlight is the Kansas City chapter of BS and Beer, which Travis is a big part of, is a founding member of, is running its second annual wall assembly competition. It's a design competition, and students are asked to present a wall assembly for their specified climate zone, considering 6 criteria that focus on building science. The submission deadline is March 19th, and judging happens on April 6th. Travis actually just sent me a blog post about the whole thing and its history and reason for being, which I intend to get up on GBA next week, so stay tuned for that. Last thing is our book club episode is coming up soon on April 1st. Everybody needs to get cracking on reading it. I know that I'm only about halfway through. We're reading Essential Building Science by Jacob Rakusin, which I think Travis is holding up right now. And the publisher is generously offering a 25% discount. And there's a code you need to enter, and I will add that as well to the chat box. And that is all I have. Mike, I believe you're introducing everyone.
Yes, first I'll introduce myself. I am Mike Maines from Maine. Tonight I am drinking a Marsh Island Brewing Pulp Truck IPA. And it is, Pulp Truck is a play on words because it is a pulpy, fruity beer. And pulp trucks there's a lot of pulp trucks in Maine. They carry wood from the woods to the paper mills. Our guests tonight, we have three guys. Each of these guys could carry the show on their own, but we thought we'd throw them all into the same room and see what happens. Kota Ino is a senior associate at Building Science Corporation, a Westford, Massachusetts based consulting company. Some of you may have heard of it. He is also conveniently sized to fit into attics and crawl spaces, which is markedly useful in this field. Doug Horgan is Vice President of Best Practices at BOWA, BOWA, the Washington, D.C. area's premier custom and remodeling builder. In this training, quality monitoring, and troubleshooting role, Doug's goal is to reduce construction defects through knowledge sharing. Doug describes himself as a carpenter with a laptop who has learned a lot about what can go wrong and is trying to learn more about how to do things right. Ben Bogie is a second-generation high-performance building obsessive working as a project manager for BPC Green Builders of Wilton, Connecticut. Recently defected back to Connecticut after we got him for a couple of years here in Maine.
And now he's with us.
And now he's back down south with you guys. I should have stopped along the way. Kota, is there anything that I missed? And are you drinking anything fun tonight?
Nope, no other information. I am drinking a Vit beer from a local brewery, Lamplighter. It's not my usual choice, but it's quite nice and crisp.
Excellent. How about you, Doug? What did I miss from your introduction?
Nothing. That was actually too much. I'm drinking Eternal Optimist from a local Silver Branch Brewing Company out of my Washington Spirit mug, which I'm determined to get some banter going here, Travis. You can try not all you like.
And Ben, last but not least, what are you drinking and what did
I'm hoping that we can get this on here. Well, this is a Trial by Wombat from Thin Man Brewing out of New York. I just got sucked in by the can. Total marketing person's rube here.
Excellent. Well, Coda is going to kick us off tonight with a short presentation, and then we will see where things go from there. You ready to go, Coda?
Yep. It says host disabled, participant screen sharing. If you can
Hang on a second.
get that.
We got to be strict around here. We can't just have anyone putting whatever they want up willy-nilly. Ben will be
Damn
showing
right.
us his beer can. Come on.
Oh, there we go. Okay. Are folks seeing the slideshow?
Yep.
Yes.
Okay, so thanks for having me on the BS and Beer Show. As always, it's fantastic to be here. They asked, they said, let's do something about building monitoring, and I'd be happy to talk about that. So a little bit of background just to understand where I'm coming from and what is this all about. So this is building enclosure monitoring that I'm going to primarily talk about. Basically, the building shell, we put a bunch of sensors inside it, figure out what's going on. So as a little bit of background, I cannot claim any credit of being like an originator of this stuff. I am merely a practitioner. The folks who, really did the fundamental work in this, or at least in North America, are the folks over at University of Waterloo. I saw a bunch of Canadians in the audience, go Waterloo. So John, that's, for those who don't know, that's John Straub's, where he teaches, and also all the folks over at RDH Building Science. Those are the guys who are at the top of the game here. So I'm not intending this really as a how-to presentation. I know I'd love to, but a lot of this is research level stuff that none of you guys actually would be able to do much of the time. But you can take a whole chunks of it away for inspiration, ideas, concepts that still apply. And just as a side note to this, a lot of these monitoring projects were sponsored by the Department of Energy's Building America program. So I always have to give a plug for those guys. A lot of great information coming out of them. So just to kind of talk through a couple of, the plethora of monitoring projects that I've been involved with, various types of vapor control, craft versus polyethylene versus a variable membrane, basement wall insulation, polyethylene versus latex paint and brick inward drive, studying drainage gaps, how well they keep your wall durable, masonry walls with interior insulation, and add on to that the whole problem of the embedded joists that are stuck in the wall after that insulation, double stud walls, comparing cellulose and open cell foam, and more recently a whole bunch of studies on unvented roofs with fibrous insulation instead of spray foam. We did experiments in Chicago, Houston, Orlando, and we just wrapped one up in Westford near Boston. We'd had a spate of doing enough of these that we actually put together our concert t-shirt of our tour from 2001 to 2005 of all the cities that we did our installs in.
That's cool.
We're that level of dorkery. So unfortunately, I'm not going to be talking about these studies themselves and the results because, I could literally be here all night talking about, breaking down each one of them. What I'm talking about more is, what are the techniques that we use for this monitoring stuff? How do we put stuff together? How do we make an experiment work? Rather than the data itself. So I don't know if you guys, there are any other of the fellow Star Wars dorks in the audience, but I kind of think of this as more of, enjoying the making of Star Wars documentary, even more than watching Star Wars itself. That's the level that dorkery that we're doing here tonight. So moving on to the actual, what are these experiments? What are we doing here? So the first thing, whenever you're trying to set up an experiment, you're not going to just throw sensors into a wall and see what happens. You want a fundamental idea of what do you want to learn? What are you expecting to happen? What do you want to know? Is this a risk that you're trying to evaluate? Performance? What do you need? What's even more what's even better than that is if you can design an experiment to do side-by-side comparisons. Like you can throw a bunch of sensors into an experimental wall and say, hey, it works great. And the question is, well, how does it work compared to the standard wall? How does it work compared to other experimental walls out there? That's something that's way more useful. So having side-by-side comparisons with the same inside conditions, the same outdoor conditions, that's a great way to do an experiment. Add on top of that, orientation and exposure. The classic way that we like to do these types of experiments, throw one set of walls facing north, one set of walls facing south. It'll often be the worst case for wintertime condensation on the north, best case on the south. It's to the point where one of the useless conclusions from one of my research projects was, if you're going to build this risky assembly, only build it on the south side of your house, and you should probably be okay if you do it that way. So what are the key spots that you'd want to measure when you're looking at this? For instance, if this is a wintertime problem, wintertime condensation, that's going to happen at the first condensing plane where interior air, interior moisture can hit a cold surface, classically the backside of the sheathing. On the flip side, if you're looking at a summertime problem, moisture getting blown in from a reservoir cladding like brick or stucco, that would be on the inside, like between your cavity and your insulation stud bay and the gypsum board. Another thing to think about when you're setting up an experiment, how long you have access to the site. It's often great when you can look at things over multiple years. Like one key thing is a lot of the time that first winter, the first year of operation, you're still drying out construction moisture. So you're going to get wonky results compared to the steady state. One of the biggest wastes of time is where we set up an entire experiment and then the builder said, oh, sorry, we're selling the house out from under you. You have to take your equipment out. That was useless. Lastly on this list, I'd recommend varying the conditions over time, like either exterior, interior, changing around your assemblies. All of these are viable things to look at. Like one big one is interior humidity. You can have an assembly that works just fine if you run it at 30% humidity in the winter, and then you crank up the humidity to 50% and it's going to start failing. Your folks in the audience might say, like, that's dumb. Who would do stuff like that? Well, I don't know. There are all these people who run dehumidifiers and are convinced that 50% is a healthy humidity, as well as what I've seen more and more is tighter multifamily construction, high occupant density, and a malfunctioning or a not well commissioned ventilation system means that moisture builds up inside. And I've seen plenty of cases with 50% humidity in those weird cases. So that's kind of an overview of this topic. So diving into a little bit more of the nitty gritty, what are the type of instruments that we're throwing inside these walls? Just examples, temperature and relative humidity are the classic ones. What I'm showing here over at the top right is a temperature and combined temperature and humidity sensor that's up at a roof ridge, likely condensing surface. Wood moisture content, that's often a great one for determining pass-fail of assemblies. When you're seeing high moisture contents, things are going wrong. What I'm showing over here are a couple of pins driven into the sheathing and a temperature sensor to go along with that. There's also a sensor we sometimes installed called a wafer, which is a tiny little piece of wood with moisture content pins in it, and it's kind of used as a surrogate for humidity over time. I often like to put in redundant sensors or things that tell you similar things, both a humidity and a moisture content sensor, because odds are one of them is going to crap out on you. So those are the baselines of the type of sensors you can install. We've done some pressure stuff, but it's kind of on the hard side to do over time, and typically it's not what we do. So back on moisture content measurements, for those of you who are familiar with a Delmhorst meter, the one where you have the two pins, shove it into the wood, it measures the electrical resistance. That's basically what we're doing, just over long periods of time, measuring that moisture content continuously. So just to put moisture content in context, if you're staying below 20% moisture content, you are definitely safe. Mold doesn't grow at moisture contents below that level. 25 to 30%, you're getting, that's noticeably wet for sure. But I would bet that there are plenty of assemblies out there in the world that are probably getting up to this range in winter, and they get wet in the winter, dry out in the summer, and they just cycle back and forth, and they're survivable. However, if you're getting up to 28% moisture content, that's when the decay fungi start to take over. And really wet wood is obvious. If you're out in the field, if you're talking about stuff in the 28% range, that's the stuff you put your hand on and you come away with it's feeling damp. Liquid water condensation is something that you have to watch out for, just because there's a lot of information out there saying that mold growth takes off when you have liquid water rather than just damp wood that has absorbed moisture from the air or adsorbed. Another thing to remember when you're analyzing data is, although you have moisture contents that might be high, it might not matter. When you have really wet sheathing in the winter and it's frozen solid for months at a time, mold's not going to grow there. It needs to be wet enough and warm enough for mold to grow to actually cause problems. So I mentioned before those wood wafer sensors. That's another one that's kind of one of my standard go-tos. It's a pretty useful tool. So it's those moisture content pins in here that are embedded in a little matchstick of wood. And it basically gives you an analog to relative humidity, basically a backup sensor. And it can also detect when you have liquid water condensation, which is when mold takes off like crazy, like you said. Also, it's a little bit of wood at a critical junction. So it's even a canary in a coal mine where you can say like, my sensor is growing mold. I guess things didn't go that well on this wall. So moving on to a few implementations and examples. So this shows a little snippet from the double stud wall where, by the way, I see the chat box flashing. I'll get to questions hopefully at the end. So what we have here is a bunch of double stud walls. We're facing them both north and south. And once again, we're doing a comparison between, a foot thick of open cell spray foam, which is what this high performance builder was using. Then he also wanted to test out cellulose because he wanted to see how that behaved in comparison. He was considering that as an option. And third is, I did 5.5 inches of foam, just trying to simulate what a normal, 2x6 type of wall would be. And basically did a comparison between all three of these, looking at the whole risks of double stud walls kind of thing. Shows a little bit of the instrumentation that we put in. The key is down here: temperature, a humidity temperature sensor, moisture content pins, and moisture content block is that wafer sensor. So you can see that we put moisture content pins in the sheathing, a little bit of redundancy, low and high. Sometimes you see effects spatially. Just as a point of information, when we're doing these types of things, we typically set our instrumentation in the middle of the stud bay, so we're measuring the typical field conditions, not what's next to the stud. Also a whole lot of instrumentation at the middle, both stud moisture content, sheathing, a couple of humidity sensors just to measure a gradient through the wall, and a wafer sensor at the sheathing because that's the spot where we're expecting moisture to build up. Changing gears a bit, here's our unvented roof assembly that we did over in Westford. So a bunch of sensors up near the ridge. These are the moisture content pins up at the edge of the sheathing. We're looking upwards. The relative humidity sensor, a wafer, and just mixing it up for having a bunch of them measuring spatially along the length of the roof, as well as on the inboard surface. To look at that, what I mentioned, inward vapor drives that come in the summer. Probably blasting through a lot of this way too fast, but you get the idea that we're scattering all these sensors. So, of course, whenever you do an experiment like this, you definitely need to measure your outdoor, your exterior conditions, your boundary conditions, as well as interior. So just as a baseline, you definitely need to measure temperature and humidity. You can do it with built-in sensors. You can do it with a hobo. Little wireless logger or, battery powered logger. The advanced school is to add stuff like a rain gauge or wind direction and speed, basically a full on weather station. For those of you who know John Straub, this is him, doing his typical attitudes towards safety on, setting up the weather station. And one good trick to know is that if you don't have the budget for a weather station, or this is after the fact and you found out that your weather data was crapped out on you, you can actually download weather data from most of the airports that are out there, hourly weather data. Iowa State University runs a server where you can just do a pull down, go to your state, and grab, specify a period, grab the full data set. It's a pretty handy trick. The type of setups. So the way that we collect, basically we run all these wired sensors back to a data logger, plug them in, they can range, and we collect the data typically on an hourly basis. I know some folks think that you need more data, but honestly, hourly is plenty when you're looking at building enclosure, building shell monitoring. So the setups can range from, half a dozen channels to this giant monster of a test hut where they paid us to look at a bunch of wall sections at the same time. And you get migraines just looking at the wiring. Another trick to know if you're setting up an experiment, one thing that you might consider is when you have your test assemblies side by side, you might consider something like we call guard bays, where it's a non-experimental bay between each of our experimental bays, just so that we know that moisture and temperature issues are not communicating sideways and skewing these experimental results. So in our roof test hut, it kind of looked like this. The green stuff is a paint-on air and vapor barrier. And then we sprayed foam into those bays between our experiments just to make sure stuff did not move back and forth there. So going to the advanced level of, you can add more stuff to your experiment to learn more things. A great one to do is to add intentional air leakage. So a lot of the time you try to build a pretty perfect wall assembly for your monitoring experiment, and then you want to know what happens in real life when we have air leakage. So, you can, you want to have something a little bit calibrated. So if you have walls side by side, you can compare them. So this is some research from the University of Waterloo, blower connected to a set of manifold pipes, flow meter, and they basically flowed in just a tiny trickle of air. This was a great one where they were looking at high performance walls, and it demonstrated, kind of obvious things. If you think about it, a double stud wall is going to be more vulnerable to an air leak than a wall with a whole bunch of exterior insulation. No big surprises. It can be high tech like this, or you can use something as basic as a shop vac connected to your manifold system. This was the Westford test hut. I know, high tech tools here. In addition to adding air leakage, we can also add water leakage. This is a pretty useful thing to know how well does a wall recover from wetting. An occasional water leak. There are a lot of assemblies out there when, if you just look at them in perfect conditions, rigid insulation, foil faced on the outside, and a polyethylene vapor barrier. If that doesn't get wet, that works great. If it does get wet, you've built a diaper of a plastic bag that's going to hold all that moisture. So the question is, how do you repeatably wet a wall? So, we thought, maybe you can just take a syringe and a hose and inject it deep inside the wall. The problem is that you end up with a trickle of water. Sometimes it runs straight down. Sometimes it runs at an angle over at the sheathing and ends up over there. So what we came up with is you put some shop towels, basically flow the water into there, and you can basically have a repeatable water leak if you put 30 milliliters of water and see how it all dries out. And this is, normally we do this with a syringe, or you can do it in a quick demonstration with John Straub would. Okay, so I don't want to go too long here. Let me just see. Yeah, I'm going to try to wrap this up pretty soon. Interpreting data. So like I said, there's a lot of ways that you can look at moisture content and as a criterion. But you can also do some calculations to show, is this assembly moisture safe or not? So what you used to be able to do is take some temperature and humidity measurements and just do a 30-day running average. And the problem was this ASHRAE 160 criteria was just way too conservative. Basically we had a bunch of monitored data for assemblies that say this should fail. And these are assemblies that we do all the time and we know work fine. So basically that was no good. So there was also something called a mold index, so basically a more advanced way to calculate the level of mold growth inside a wall. And that basically stopped giving us the false positives, but the takeaway is maybe it's passing some assemblies that might have some mold risk. So the jury's still out on some good computational way to say, is this thing mold risky or not? Where we might have stuff a bit on the conservative side or not. But what I really like is at the end of the experiment, opening up the walls or the roof tells you a heck of a lot. You see some stuff from data, but coordinating that with what you actually see inside of it, you learn that much more for sure. So for instance, at the end of our double stud experiment, they got out the scaffolding and we pulled off some of the sheathing to take a look. For instance, some of our data said that we had condensation in the cellulose walls and that we should be seeing some pretty nasty, possibly mold growth, stuff like that. What did it turn out? No, actually, we had some, rusted staples, couple of, nail heads that looked bad, some grain rays on the sheathing. But on the scale of things, I would not consider it a disaster. So it's always useful to have that feedback from the real world of what it actually looks like. Another thing, where we were looking at data and scratching our head, we had this experiment in Canada where we were comparing on the left a 2x4 wall with an inch of foam on the outside, then a 2x6 wall with paint on the inside, just latex paint, and a 2x6 wall with poly on the inside, running it at 50% humidity in a Canadian winter. And so we looked at our data and, so the poly wall looked all kinds of boring throughout that winter. Paint, we saw this weird spike over here, and this is the moisture content of the sill plate on the outboard side. So that would be, right around middle outboard there. And then when we looked at our 2x4 and foam wall, it's like, whoa, something bad happened there. What, is this reality or did our sensors go crazy and did we lose something? What we're showing is, basically the sill plate got soaking wet right there and just slowly dried out over time, but it was super wet. So 40% plus moisture content. And when we disassembled stuff, we found like, hey, that wall does not look healthy at all. Yeah, we got, a whole lot of black growth on the outside of that sill plate, all that spotting on the foam. And then when we looked back at our data, when we got the giant sploosh of water over here, that is when the inside surface of the foam went above freezing. So we had a whole lot of frost building up on the wall. The sun came out, warmed it up to freezing, melting, and we just soaked the sill plate. Answer solved. So that's the rundown of, building geekery with building monitoring. Kylie, do we want to, answer a few questions or just move to everybody else?
I haven't been watching the chat box. I'm sure there's plenty of questions. Typically, we'd love to have the other panelists, guests weigh in at this point. I can't remember if you all had other things you wanted to share visually. Is that true?
Well, I think we had quite a few questions for CODIS, so maybe before moving on, let's just address some of those.
Okay.
Yeah. Thank you, Coda. That's another college semester course in 20 minutes. That's holy fire hose.
Holy Moses, right?
That was good though. That was great. Thank you.
Awesome.
We had quite a few questions. June wondered when you talk about fibrous insulation, is that something specific? Is it fiberglass, cellulose, mineral wool, or is it something more specific than that?
Exactly. Fibrous insulation, we were in this unvented roof study, we were looking typically at a comparison between fiberglass and cellulose as the most common materials.
Okay. Rob Spewak wondered if you play around with heat flux sensors.
We have used heat flux sensors in a couple of instances, but honestly, most of the time we're looking more at the moisture side, and honestly, a steady state, The calculations that are out there do a pretty darn good job if you know the R values of being able to calculate the whole R value of the wall. We're not going to learn too much more about with a heat flux transducer about what we're actually getting through the wall in terms of temperature. The exceptions would be like when we're playing with thermal mass or like a phase change material, that wacky stuff. Sure, that is a good application for them. But lightweight construction like this, probably not.
Okay.
Yeah, the only place I could see heat flux coming into effect is if it's like a new assembly, if you're trying like a new hempcrete assembly or something like that, where there's very little data out currently. That's the only place I'd really think about applying heat flux sensors.
For the less educated among us, can you explain what a heat flux sensor is? Heat flux I know is the change in temperature, but what is the sensor and why would you use it?
Yeah, so a heat flux sensor is basically a way to measure how much heat is flowing through the plane of your wall or like a subsection of it. And I believe there are, some really carefully calibrated thermocouples and a couple of surfaces that actually tell you what the heat flow is across that as a result. They're like, if you think these humidity temperature sensors are expensive, heat flux ones are, another notch higher than that.
Okay, got it. This is an important question. Armando wants to know if Building Science Corp sells psychrometric chart T-shirts, and I think others are also interested.
That was from Allison's post today. I think you saw that.
Yeah, it wasn't us. Who was making it? Was it Henry Gifford or somebody else? But somebody out there makes psychrometric chart T-shirts.
Let's see. Kenneth Klassen asks, have you done any long-term multi-year studies of air tightness to see how it changes as a building ages?
I've not done any studies of air tightness over time, but there are a couple of good ones out there. One of my buddies in Canada, spacing on his name, out west, Winnipeg or something, he went back and tested a bunch of airtight drywall approach houses after a bunch of years, and the takeaway was like, yeah, unless they actually cut a new hole in their house, it's the same. There's probably a limited data set. It's probably not a monitoring experiment. It's more of a go back and measure the house again experiment.
Yeah, that makes sense. So just blower door test it again later, and that's all you have to do.
Exactly.
Yeah. Kenneth again asks, what's your opinion of wired versus wireless sensors and data collectors?
Yeah, wired versus wireless. In a lot of the research that we're doing here is wired sensors, just because we have such a big concentration of them that it makes no sense to do a wireless setup for stuff that's, basically we have a grid of all this stuff buried inside the wall right next to each other. We bring all the wires back to a central collection point and then back to our logger. If we were more spread out, doing stuff with wireless probably would make more sense. One of my cautions is, a lot of the wireless boxes are bulky, so they're displacing insulation. It would be nice to have side-by-side comparisons to know, is this something to worry about or not? But that's about all that I know.
I can chime in there a little bit, just because we've had this discussion a little bit, Coda, about them creating physical aberrations in the readings you're getting from the mass of them actually existing in the wall. The OmniSense ones that I use, I've actually switched over recently where they have a remote probe, so it's very similar in form factor to what you're using. Exactly for that reason, I'm trying to be discreet as possible for, creating disturbance in the wall. So
there was other chat in there about relative humidity. Bill Robinson asked specifically about hot and humid climates, 50% relative humidity not being good in colder climates, but hot, humid climates, 50% is okay, and how the northern cold climates data would be different than southern climates and that whole exchange.
Oh yeah, sorry. I apologize. A lot of my research has been very Yankee centric, where we're looking at cold climates and condensation and all that kind of stuff. So when I was talking about 50% humidity, that was more specifically 50% in a cold climate winter that I'm worried about. That's the kind of thing that rots walls really easily. 50% in summer, whether we're in South Carolina or in Massachusetts, 50% humidity inside is like, hey, your air conditioner is doing its job. Good stuff.
Fair point.
Or as Dan Colbert says, only a fool would live in a hot, humid climate. That's the other answer.
Agreed.
I feel like we can't really make our nut on our building science advice if we always end with, well, you just shouldn't live there.
Yeah.
You're in conditions that aren't working with your assembly, you should just move.
Yeah, that's kind of the universal building science response. If the answer isn't it depends, the answer is don't live there.
So should I give the screen back and the other panelists can do their thing?
Yeah.
Okay,
yeah.
stop. There we go.
And Doug, we talked about maybe discussing CODA kind of covered building enclosure stuff. We were going to maybe talk about mechanical stuff. I know this is kind of a broad-ranging free-form situation, but what do you like to do, or what do you do differently than CODA, and do you do what do you do for mechanical system testing?
Yeah, first of all, I just love hearing CODA talk. That was amazing. And if you ever run into him, amazing, great guy, very, very fun and very willing to share, helped me out a lot with this stuff 10, 15 years ago when I was getting into it. So that was great. And I actually had a picture on my cubicle for a while with like one of those monitoring setups with the 15 things inside the wall. I was like, oh my God, this is so incredible. If only I could be doing this. I don't do that. First of all, I live in a climate where we really rarely have these issues. And when we do, we know how to fix them. So, moisture accumulation stuff. Although I'll just throw this in. Any of you in Yankee-centric areas should be very afraid of what summer is going to do to your buildings if you're using interior vapor barriers. But that's an aside we can talk about later. I do use data logging a lot because getting the recordings over time is incredibly helpful with a bunch of different types of problems. And I'm not sure how much time I should take up of everyone's. So I do have a couple of things that we can talk about. Let me just jump into that. Oh, if you can enable that for me. And we'll just see how this goes. I mean, actually, it's really interesting. A lot of the lessons learned that CODA talked about are the same things that I learned by doing them wrong and losing all my data and all that kind of stuff. So, all right, let's see how this goes. As mentioned, I end up doing a lot of HVAC diagnostics and stuff. A thing that happens a lot with us in remodeling is this room's too cold, or this room's too hot, or too humid, or too whatever. And sometimes you don't even really know how bad it is. Particularly, I'll say when there's a younger person who lives in the space, it's a really good idea to get some cold hard data about what's actually going on before you go jumping through hoops, because I've seen all kinds of interesting stuff. Let me just talk about some of that. So my typical HVAC investigation setup, I would get the outdoor conditions, usually including relative humidity if it's a summertime issue. I like to record at the thermostat in the problem room and also in a space that's not a problem, because sometimes we've actually found that the problem room and the other rooms are behaving the same, and it's just the clients are using a big setback or something, and the kids don't like it, and the clients don't think it's a problem for them. And then it turns out that there wasn't really an HVAC issue at all. One thing I did learn is I used to just put a recorder on top of the thermostat, and then they came out with these communicating thermostats. So I'm finding that I'm reading 9 degrees higher than I should be, because a communicating thermostat is a computer and it's got a plume of heat coming up out of it. So instead of doing that now, I stick it somewhere nearby. I often use these onset hobo loggers, which were mentioned earlier. they're, I think they're at a good price performance point. They seem to be pretty reliable. I'm still using ones I bought in 2001, even though I have to use an adapter to connect them to a computer to get the data. So they've held up pretty well. Anyway, these newer ones have magnets on them. That's nice. All right, I got a little quiz for us here. Here I've got sensors in a bunch of rooms, and one of the rooms I'm getting these spikes. What? Anyone have any ideas about what that could be?
Looks like some wicked knitting going on in there. Because, I mean, crazy yarn
Yes,
friction
in
is
the
all
knitting
I
room.
can figure.
Exactly. I really should change this. Yeah. Yeah. I try to think through where to stick these things. I don't put them on a windowsill where it's going to really be reading the temperature of the window, unless that's what I want. And I thought I had stuck this out of the sun, but it turns out that I had stuck it in a place where the sun directly shone on it for 20 minutes every day, which completely screwed up my ability to use averages. And this house was, the owner of this house was a super high powered businesswoman, and she didn't even like these graphs. She wanted the actual numbers. She wanted the spreadsheet, and she was using all these functions on them to see. It was really amazing to watch her work with the data. And this was a real problem for us that I put it in the sun. So now I know you just find some junk that people have on their shelf, and they all do, and you stick it behind the junk, and then you're out of the sun. So yeah. Obviously you want to keep it away from where the air is blowing on it too, unless that's what you're trying to catch. The other lesson from that one was get rid of your terrible HVAC contractor and find one who will fix your problems. But I didn't tell the whole story, so you didn't get the whole thing. Another thing that I found accidentally very helpful is I used to start these and then stick them in a Ziploc bag and throw them in my backpack and then run out to the job. So my first few readings were all the loggers were in the same place at the same time in the same conditions. So I was kind of doing a check to make sure that they were working correctly when I get the data off later. And are these working correctly? Well, one's reading 0.7 of a degree off. For the most part, that isn't that important in the analyses that I'm doing. So, and if it is, I can just add 0.7 of a degree to that one. But it's good to have them in the same place every once in a while. When I look back on it, I've had a couple of humidity sensors go bad, probably because I put them where condensation got into them, and the ones in most of these can't handle that. So it's good to know if your measurements are all screwed up. So then, you just wait. Usually the way I do it now is I look at when the outdoor temperature falls from the temperature of my backpack to the outdoors. Then I take off those lines and throw them away. And now I have real data from there down. Pretty simple stuff. One other thing that's really interesting is we're trying to interface with, not with people in academia and architects. We're talking to civilians, right? To homeowners, and how you present the data can really make a big difference. So in this case, I'm looking at a condensation on window frame issue, and I'm looking for where the window frame temperature in purple goes below the dew point temperature in the room in yellow. And I can just say to the client, so, here's where we're having a problem, here, right here, and right here. And that's when the outdoor temperature gets below 25. And that helped them understand what the issue was and helped us all agree to a solution. On the other hand, when the engineer came, I handed them this thing with all the other lines on it so they could write their report. All right, we already talked about all that. And one other thing that has happened, or that we've ended up doing, I agree 100% with Coda that 1 hour monitoring, if you're doing something for a season, 1 hour is great. Mostly for HVAC, I'm doing 10 or 15 minute recordings, but there are some situations where I'm looking at much shorter situations. I end up getting into these, why is my zone damper system not working situations a lot. I actually have 9 sensors on a house right now trying to figure that out. But we often set them on 1 minute readings when we're trying to see exactly what's really going on with the HVAC system. A whole run cycle on an HVAC system might be under 10 minutes. So if you want to get the data, you got to do much tighter recordings. And let's see. Oops. Yeah, I got a lot of data out of that one. A lot of data. This was not something I'd put in front of the clients. But one of the other interesting things I'll get to in a second, one of the really great things that's happened lately is that a lot of fancy thermostats they'll take readings and they know what state they're in. So I always have this question. I can kind of tell when I have a logger at the thermostat. When they change the temperature by 2 degrees, I can pretty much tell. But with these logging thermostats, I can see exactly what temperature it was set at and what mode it was set at and that kind of stuff, which again, especially if you have teenagers in the house, is really helpful for diagnosing problems. So these are great. I will say that, some of them make life a little bit difficult. I have this one file. Now, to be fair, the manufacturer said it's best not to record more than a few weeks at a time. But they didn't say why, and they didn't say exactly what would happen. Well, what happens is you get 170,000 something lines per month. So this is a spreadsheet that stopped trying to open at 1,048,000 lines and said can't open file, and made me reset my computer. Anyway, you have to be a little bit careful. So that's again. The other thing that's interesting is we bought a bunch of humidity, temperature and humidity sensors. And even when I thought I was only looking at temperature, I would have humidity. And it ended up being really helpful. Like one room was always too hot in the afternoons. And the kid who lived there would take a shower without the fan on and then open the window. So yeah, the room was too hot. And how did I figure that out? Because the humidity level went through the roof. So I knew something weird was going on in that room. So it turns out that that's very helpful. And then just keep doing stuff over and over. And then I can wrap this up here. I love this quote, and it's been, this is what I found is the most valuable thing. When you're working in someone's house, there can be a lot of emotions. You're working with a smart, successful person. They probably have a theory about what's going on. It's probably completely wrong. And it's much easier to talk it through if you can just say, well, if you look at how this temperature goes here, I think what we're looking at is this. And then you're helping them solve the problem. You're not throwing an opinion back at them. Well, that's my 2 cents.
Doug, I really like that one, and it resonates with me because I caught some flack from somebody I respect recently who thinks that I'm wasting my time by monitoring buildings because we can use things like modeling programs to predict what's going to happen. And my argument with that is that we've already learned that the models are only as good as the people putting the inputs into them. So if I'm not collecting data, we have nothing to compare to. So maybe, best case scenario is that we find out that the models are absolutely correct, which is great. It means we can use them. Or maybe we find out that they're not. But if I'm not collecting data, we'll never know. So.
Yeah, and I'm hoping you'll pull up that screen and show us what OmniSense gets you. Another thing, before you do that, a question I have for everyone is the price. There's new options have come out that are much less expensive than, in 2001, when I dropped $500 on a bunch of onset hobo loggers, it seemed like a lot of money, but it was a miracle that you could get that, and it worked, and it was easy. But nowadays, you can get communicating ones that have Wi-Fi, and for like $150, you could get the same equivalent, seemingly the same equivalent group of sensors, even with extra features like connecting to the internet. And my question is, are people having good luck with that or not? And I'll just say I've tried a couple of them, and I'm not in love. I really need the data, and I'm willing to pay a little bit more to make sure I get it, is my current opinion, but I'd love to hear more about that. And then OmniSense, of course, is way more expensive. So now I'll turn it to you.
Something before I share my screen that we haven't really talked about yet is we've talked mostly about hygrothermal monitoring here. But something that comes into a lot of practicality, I'm sure Doug's dealt with this, is like zonal pressure diagnostics. So using a manometer and closing doors in houses. I had a client a number of years ago who at night, his master bedroom suite was getting freezing cold, and they couldn't figure it out. HVAC guy couldn't figure it out. So what we ended up doing is we blower door tested the house, and we found some leakage around some can lights and stuff like that. But then what we did is we depressurized the house, and I closed the doors. No, I'm sorry, it wasn't depressurized. We had the HVAC system on. We had the air handler on. I started zone checking each room, and I found out that the master bedroom suite was strongly negative. What had happened is, because of the size of it, is there was a return in the suite that was functioning, and there was a supply damper that had basically closed completely, so it was drawing a negative pressure on that room. There also happened to be a Garrison style bump out of the second floor right over it, and an open soffit with no air sealing, so it was drawing all this cold air in and pouring right down from the can lights over top of their bed and just showering them in cold air. And we probably would have eventually found that out, but by doing some of that pressure checking, we were able to quickly realize something was going on with just this room. It was a heating system issue, but it wasn't a broad heating system issue. It was a localized heating system issue. So pressure diagnostics is another great tool. So let me go ahead and share screen here. My interest in monitoring, is this showing up for everybody?
Not yet.
Not yet.
Did we grant you
Oh,
permission?
I'm sorry, I got
We
it.
did.
I got to hit the.
Thank you, Kylie.
Are we there now?
Now we're
Yep.
good.
Okay, so hopefully Dan Colbert's not upset that I'm logged into his data, but I can illustrate a good point here. These are monitors that I installed with Dan. I can log into mine if you're upset, Dan, but there's some
Hey.
good stuff that we can show here.
I didn't do this with an HVAC company that
He says he
could have.
has.
I was like, oh, I can show some live data, and I was like, no, I probably shouldn't show that I still have their password.
It's all right. He flames me with hate mail on a daily basis anyway, so there's nothing new going on here. So my interest isn't so much anymore in diagnostic or like a acute monitoring to solve problems. Mostly what I'm doing right now is I'm monitoring new construction and substantial renovations to see how they're performing and just really educate myself and just gather this data. You know, I might not be smart enough to break down what all of it's doing right now or telling me right now, but if I'm not gathering the data, by the time I get smart enough, I'm going to look back and regret that I don't have data to draw on. So I'm trying to accumulate data from, you know, new builds and funky low energy assemblies and stuff like that. And I do that using OmniSense monitors. So real quick this is OmniSense's website. I'm not affiliated with them. These are just monitors that have worked well for me. I mostly use these little guys right here. What they are is they have two screws that mount them to your material. Those act as wood moisture sensors, pin moistures like the Delmhorst meters that Coda was talking about earlier. They also give us temperature, relative humidity, and absolute humidity. I can bury those inside of assemblies wherever I want them. The ones that I've recently switched over to using because of that concern Coda had about the physical size of the sensor creating a abnormality in the reading are these. They have a little remote wire probe that comes off of them. I can stash these inside of the envelope somewhere and then just run the little wires out into the assembly. And those all communicate back to a thing that looks like a wireless router right here, and I access it remotely. Something Coda mentioned in the past is how long you're going to have access to the projects for. Historically, we've had these gateways hooked up to Wi-Fi in the client's house, which can be a little bit tricky if they change Wi-Fi passwords and stuff like that. You have to find out from them. Recently, I've switched over to doing cellular data loggers, so now they can exist completely in the client's home. As long as they're plugged in, they will continue to gather data and transmit it up to the cloud for us to view. So this is what my interface with my data looks like. Essentially, we have our jobs right here, and we can go into them. There's some basic information about status of gateways and generating reports here. But what I can do is I can go into my sensors. And what we'll do right now is these are the 4 sensors I have in the building, looking at, I think we have 2 roof assemblies, a wall assembly, and then what was a wet section of a basement that we wanted to keep an eye on. So these are, let's see, where do we want to go? Good. This is a 10-inch thick double stud wall. Sorry, wrong one. 10-inch thick double stud wall. So what we can do is we can go and we can select data for the last month and we can see what's going on. This is the temperature in here. I can then go down. So these are all my sensors, temperature. I can also watch my relative humidity and refresh here. So you can kind of start to see another thing that's handy to do is you can do temperature and dew point. And you can, like Doug was doing before with his condensation on windows, is we can look for those lines to cross. As long as they're not crossing, we're not potentially in the risk of, condensing water inside of the assembly. But something fun to do, and this is part of what drove us into this, was the concerns over double stud walls, is that, like Dan called it, it's the Yeti of building science. Everybody thinks it's going to fail, but nobody's really seen it happen yet. So what we started doing is we wanted to monitor and watch what's actually going on. And what you can find is we're right at the right time of year for it right now. Sorry, let me get the data that I want to show. What we can see is our yellow line, which is our relative humidity, which is quite high. It's, showing 87% or something like that. I consider that quite high. This is the full load of what we're seeing at the end of winter. And now what we're seeing is we're starting to see the temperature come up into that range where we could start to have fungal growth or decay organism growth, but we're seeing the moisture start to come back down into a safe range. So it allows me to seeing this data right here allowed me to really start to understand with confidence what's happening inside of that wall. Everybody knows that they're going to load up at the end of winter, and then the season's going to shift and they're going to start to dry to the exterior. This allowed me to see it in real life. And we're actually, this is last week. We're right in the time of year where this is happening right now. So this is kind of cool that we kind of pulled this data up live. But this is the type of stuff that you can get with data logging. On a nerdy aspect, Dan and I started to toy around with the assemblies. We're doing double stud walls. This is a double stud wall with 5/8 zip on the outside of it. Then we built a building, which was a double stud wall with 1/2-inch CDX and a high perm WRB on the outside of it. And we're trying to build different assemblies, and we're trying to monitor different assemblies so that we can start to see how these actually react and if they respond to what the models lay out as they should be doing. So I just kind of wanted to give you guys, I don't have any great presentations. Coda already killed it and Doug killed it. So I just wanted to show you a little bit of what the back end of what I'm looking at when it comes to the data is. So,
yeah, that's great, Ben. Thank you. I still haven't logged on to the project I was involved with. I need to one of these days. You guys also measured on that one electrical usage. I can't remember what the measuring device was called.
Okay, so yeah, so electrical, that's something else that we haven't really touched on. We can really start to expand our sensoring of buildings, and I'm starting to kind of branch out a little bit more. That project, we used one of those sense monitors. Everybody's, I'm sure, seen the ads for them. They're a couple $100. You put them into the panel, and they use machine learning to understand what the different loads are. They're okay. They're okay. The problem is most of our projects we're using, inverter-driven heat pumps, and they don't do well with those. So that's one of the big data sets that we want to see. Is we want to see what the HVAC system's using, and they just don't respond well to that. Recently, on a project Dan and I did together before I moved, we used who's the panel made by? It's the Leviton, yeah, the Leviton Load Center. And that has circuit by circuit monitoring, which is a great way to kind of be able to watch. We watched 3 or 4. We're watching ventilation system. We're watching HVAC system. We were watching in-floor radiant electric heat in one of the rooms. The large load stuff, that's the stuff that we really want to keep track of. One of the things that I'm starting to branch out into now with OmniSense is doing, there we go, CT transformers. So one of the reasons I really like OmniSense is that it gives me a lot of breadth of sensors to do. I'm just really starting to tap into them. So what I'm going to start doing now is using the OmniSense CT transformers to monitor loads in the house, as well as doing funny little things like monitoring when the range hood is turned on. so that I can compare that to watching indoor VOC spikes and particulate spikes and humidity levels in the house. So if I start seeing a spike in the kitchen and I see that the range hood's not on, I can correlate to see what's going on there. One of the other areas that I can't really do it so much with OmniSense, but I'm investigating right now, is a better quality IAQ monitoring inside of the home. So, you know, everybody's becoming more and more aware of the IAQ, especially with COVID and everything. It's become a very hot button topic. But I want to be able to watch and see what our ventilation systems are doing. How are they responding? How is the quality inside of the building? What can we do to adjust it? We've done some stuff with, you know, the off-the-shelf, the Fubots, the Yoo-Hoos, the AeroWares, that type of stuff to watch. They're not terribly accurate. I'm in a position where we can do it now. I'm going to invest in some better sensor equipment so that we can gather like real data that we can actually look at over a long term and have faith in. So that's kind of where I'm at. Something that Coda mentioned before, so doing exterior temperature condition monitoring. What I do is instead of monitoring each project outside is we'll put one, and if we're building a lot, we generally build in a similar area, so I'll just have one exterior on one project and I'll pull that data from exterior conditions for other local projects. So I don't have to be buying a bunch of sensors, but that's where I'm at right now.
Excellent. Thank you.
I want to thank Doug for pulling the panel image off the screen. It was making my skin burn, so I'm grateful. Are there less scary looking ways to monitor that? So, you know, other than the Leviton panel?
That's funny. So that isn't the Leviton panel. That's
a CH.
Yeah, exactly. That one is that's the Emporia View, which I just got too, and Allison Bales was just saying he's getting one. That's a circuit by circuit monitoring thing that's actually somewhat affordable. It's like under 200 for 16 circuits. And I had a picture of the software on there too. I'm having a ball with that damn thing. It was not a ball to install. It was honestly, it was a little scary. Like, it's one of the things where they're like, make sure you turn this off. And I'm like, oh, pshaw, who turns off electricity? And then halfway through, I was like, I'm turning this off. Like, I'm going to touch this sooner or later. Anyway, that's really good stuff. And then on the indoor air quality, like Ben said, it's amazing the stuff you learn. I actually think one of the most incredible learning experiences I've had is I bought an Aware, and the Aware is, you know, it's probably the best cheap one, I guess most people would say, now that Fubot's out of business. But it has a legit CO2 monitor, and the stuff I found out about how air moves in our house and what rooms are ventilated properly and not just totally blew my mind. And I really highly recommend getting at least one of those and playing around with those.
Are you finding that behaviors change? That's always my concern with monitoring. Like, it's really great to have the data, and it's really good to learn from mistakes, for sure. Like, if I have a failure in something that I built, I don't repeat that failure. And so I feel like this entire sensor technology is a great way to avoid letting it get all the way to failure and fixing it in advance of the failure. But if you don't...
Well, Doug just shared some information with me along these lines that sometimes the fix is super simple, right? Didn't you say that shutting your kids' doors at night was a big problem, and it was the data that you collected that you figured out that was not a good idea. The carbon is better to leave them open, right?
Right. Although at the time that we figured that out, that kid was not going to open their damn door. That was so we had to turn our furnace fan on a cycle. You know, I had an advanced thermostat, so I could run it and see how the CO2 was staying in the room, and ran it as little as possible because I hate spending energy. And now that I have an Emporia and I realize I'm burning 850 watts when that thing is running, I'm really glad I ran it as little as I could. But yeah, Ben, what were you going to say?
I was just going to make a joke that one of the great things about monitoring is you can anticipate tricky phone calls before they come, and you can avoid them and just hit decline.
Change your number and re-register with the state before it
call your lawyer. Yeah.
Are your clients really involved in the data that you're collecting, or does it really vary? I mean, how interested are they? How bugged are they by it? I mean,
it does. I think when I first tell them that, like hydrothermal Big Brother is going to be watching, there's kind of like a little inquisitiveness or a little fear, but then they start to, warm up to the idea. And most of them at first are like, oh yeah, we can't wait. We'd love to see that. But by the time it's time to move in, they're more interested in, where the TV is going to go and where the couch is going to go. And they forget about the sensors, which is fine with me. I'd rather them kind of exist. I'm kind of jealous at Coda because you guys can run wires and stuff all over the place. Not only do I have to figure out how to monitor stuff, but I have to do it hidden from the clients because most of these clients want to know nothing about it. They just, that box that I leave with my wireless gateway exists in the utility room, and that's it. They'll tolerate that there.
I think that's the beauty of the balance of the panel tonight. We had Coda basically telling people how to test, the best ways to set it up, how you would successfully gather your data. And then we've got Ben with the actual field monitoring of similar assemblies. And then Doug taking us right into a whole nother realm, talking about ductwork and HVAC performance. I think this is a perfect balance. And I'm kind of excited about this. And I'm definitely into dorkery. I'm all in. I don't have that full Star Wars outfit in the closet, but I'm down with the dorkery. But this is pretty next level. This was when I read Ben's article on it, when I reread Doug's article that he reposted. This is something that I think for the average Joe builder or building science enthusiast is previously almost a bridge too far. But now you guys are kind of bringing it into the fold where I feel like it is going to become more commonplace. And I'm certainly more appreciative of the understanding that you've endowed upon us, because again, if we're not measuring it, we don't really know anything. You made a great point about the energy modeling is kind of a best guess. If you're not verifying with the data and frankly, without controlling the install and controlling all the other field conditions, the energy modeling can't ever really be accurately achieved. This is the next level. I don't know. I'm super stoked about this. I don't know if the prices are as low as it sounds like they are for this. Why somebody who's running blower door tests and actually who cares about their performance, who's not going to do this? This is great.
It's something that's really easy and a low cost way to start to get your head into this is to buy one of those onset hobo monitors like you have and put it in the building during construction and watch what happens during construction. When you start to see, like the first time I used the OmniSense, I would watch the morning when the drywall tapers would show up. And you would watch the humidity load would blow your mind. It would be 95% humidity in there at like 75 degrees because they've got the heat going. It's just like the amount of moisture. You just start to ingrain that understanding of what's happening with your buildings and the assemblies. And, it's a much more finite, understanding of what we're doing with these buildings. And especially if we're pushing from tighter buildings and lower energy flow buildings, we need to start to be aware of this stuff. So, but it doesn't have to be fancy. Just, toss one of those OmniSense or, one of the hobo loggers in there and just get a sense.
One of the things that the intro said was, what should we be monitoring? And one of the things that I really like about the smart thermostats is most of them, they have you can set alarms to go off, and you could do that for humidity, which to me, that's my big worry a lot of the time, is that a client, either they have a leaky, crappy house that we did the kitchen in, and their humidifier is going to break or not get turned on, and their humidity is going to be 17 for a month. And then they're going to call us and say, why are all the panels on my cabinets look funny? And if I had an alarm, I would call them and say, hey, your humidifier is broken. Or vice versa in the summer, or vice versa in the winter. If they have 3 steam humidifiers and they're running the house at 60%, I can tell them their house is going to fall apart. And they can do that if they want, but they probably don't want to do that. Anyway, that kind of stuff is great. I will say, I was on vacation once and my phone just started going ding, 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 ding at 4 a.m. And I was in another country. And so one of our clients had 5 systems hooked up over the internet, and their power had gone off and then back on and then back off. And all of the systems alarmed in every way possible. And I got 3 texts and 3 emails from each of the 5 systems all at the same time at 4 a.m. So I don't know, again, you got to be a little careful, I guess. But at the same time, it was good for me to call them and say, hey, I see something's wrong with your air conditioning. And they were like, you just got hit by lightning. We don't know what to do. But, that was better to hear it in that direction than the other direction.
Yeah, but by pure luck, at a place I used to work, we actually discovered a roof leak when the humidity sensor spiked, and just it was really lucky. Well, it was unfortunate that it leaked, but just it was really lucky that we could see the spike in that one spot. Gail has an interesting question. Do any of you have data on natural wall systems such as straw bale, cob, hempcrete, different behavior from conventional systems? Have you data logged it? Have you heard about data logging yet? What would happen?
I personally have not, but John Straub has done a whole bunch of work with the straw bale community, throwing all the geekery at the straw bale natural world and, measuring vapor permeance of natural plasters and things like that. And I know for sure that they have logged a straw bale winery in Sonoma Valley. What the results are, I do not know, and I'm sure they've done other ones, but I don't know what the data came up to. But I think that one of the takeaways are, stuff does work pretty darn well.
I haven't done anything like straw bale or hempcrete or anything like that, but I'm currently doing a project which is kind of a non-typical assembly. It's a 2x8 frame wall with sheathing to the interior, and then 60 millimeters of wood fiber insulation to the exterior, and an interior 2x4 service wall and vented rain screen. And then the roof is very similar with multiple layers of venting and wood fiber insulation. I'm bearing quite a few sensors into that to try and understand as much of it as we possibly can. Modeling wise, it should perform phenomenally, but I want to see numbers that back it up. So.
A question going back, I can't remember when this came up, but I think maybe it was at the end of Coda's presentation or afterwards, but or maybe it was the beginning of Doug's. But is it a problem if your humidity sensor can't handle humidity? There was one project, or my first and last data logging project, we lost half of the sensors. Like, I had chosen the ones that were supposed to be moisture resistant. I didn't talk to Coda first. I talked to him afterwards, and apparently the whole system was the wrong choice. So lesson learned, but just how much of a problem, if you're trying to measure humidity and moisture, how much of a problem is it if your sensor can't handle it?
Yeah, unfortunately, it is the nature of the beast that the current generation of relative humidity sensors, it's called like a polymer capacitive sensor. If you hammer it with 100% relative humidity for a long time, it's going to die. I have a bunch of projects where the data goes up to 100%, 100%, 100%, dead. And, that's just what happens. So I mentioned in my presentation that little wafer sensor, the little block of wood. The thing is, that one's going to survive being hammered at 100% humidity when your RH sensor dies on you. I had another experiment where the RH sensors died, and we went in, okay, year 2, we snap in U sensors.
Excellent. So on my project, it's probably not good news then for if all the sensors died.
Yeah, just on a previous point, Ben was talking about the Sense, the electrical monitor system. Yeah, I have one too, and I totally agree that it does a pretty half-assed job of recognizing stuff. Sometimes it's good, sometimes it's like, what are you talking about? But I don't know if you've seen the newsletter update that you can grab the spare CT opening and monitor a subload. So that works for at least one mini split heat pump.
There's a bunch of them coming onto the market too. I know there's the Iota Watt, which is one that I've had my eye on for a while now. I'm curious about this Emporia too. I was unaware of that one, so I'm definitely going to be checking that out. It's all of this technology that the cost to actually physically produce the sensors is coming down so rapidly. They're no longer in Coda's realm or the collegiate realm of monitoring. They're getting into the realm where we can kind of justify the cost.
Exactly.
Due diligence.
Yeah.
Drew,
Go ahead, Mike.
Drew asked earlier. I thought he was asking what's everyone's favorite T-shirt based on previous conversations, but actually he was asking what's everyone's favorite T-stat. What thermostats do you guys like? Whatever.
The ones that work with the system we're installing.
Yeah.
You're kind of stuck. Yeah. But I guess it just seems like all the companies have come out with ones that track way more stuff and store it and send it to the cloud. And, Carrier's latest thermostats, they cost more than a computer. It's kind of obscene, but they allow you to test zoning systems all the time. And I saw Allison posted in chat, don't do zoning systems. I could not agree more. They're terrible.
Agree.
Mostly, if you have a super high-end air handler and a branded zone damper system, and you're smart about it, and you only do 2 or 3 zones, they seem to work reasonably well, and they don't necessarily cause everything to wear out and break right away. Having said that, it increases the level of complexity on something that's really important for your happiness in your house, and you have to weigh that out. Also, if you don't have a ton of money, you can't do all that. Anyway, having said that those thermostats make it really easy. I mean, just dial it up, put all the air to zone 1, walk around and make sure zone 1's tied to zone 1, which is the most common error I find, is zone 1 is tied to zone 2. And it makes it easy to do stuff, and it tracks how much electricity it uses, what settings are at. They're really great.
Something that we haven't mentioned that Doug's comment just reminded me of is commissioning. When you complete a project is actually going around and testing your airflows and checking your dampers and your ERV. Like, this is, your HVAC companies are supposed to be doing this, but nobody does it. I feel like I'm the only dum-dum who walks around on any project I've ever been on with a flow hood and checks what they are, aside from the Zender guys who come out and commission their systems for you. But it's simple, I'm sure you can either buy or find somebody with a flow hood and just check your flow rates. If you have a manual J done for your project, which you should, it should have your recommended flows for your rooms, and you just go around. Is it doing what it's supposed to do? There you go. That's it. Just check them. You'll save yourself a ton of hassles just by doing that.
This computer microelectronics revolution is changing everything. You can there's a bunch of suites of sensors you can put on your air conditioner or heat pump, and it actually combines all the data into one place, checks it with the cloud, and verifies that all the pressures and temperatures are in the correct operating range. Does stuff that only a really seasoned master technician with a ton of time would ever have been able to do. And now if you buy this $700 set of tools, any idiot can do it. It's good stuff.
Yeah, Doug, I think that some of the manufacturers were talking about having systems that do self-diagnostics. And one of the big pushbacks are that the installs are so crappy that half of them would fail, just as a baseline.
Oh, you're on mute, Doug.
I'm on mute and I'm trying to share my screen, so I wasn't even on screen. Yeah, I agree with that 100%. Actually, the other thing that can happen is if you put in a furnace with an electron, and you actually wrote the paper on this, the putting in a furnace with an electronically controlled, electronically commutated fan, they'll ramp up to give the proper airflow. So they might use more energy if you have crappy ductwork. Or what happened to me was when you got to a cold day, they would turn off because the static pressure was too high. It would run fine on low speed. And none of us were, no one was testing static pressure. This was 15 years ago. We found this one. So yeah, I agree with that actually, especially in a renovation situation, we don't necessarily know what we're working with. Yeah, but those Carrier thermostats will tell you the static pressure on the system. And when it's good, you're like, wow, that's crazy.
It's under half an inch.
Yeah.
That blew my mind when you shared that before, Doug, and I saw that there was static pressure right there in the thermostat. That's awesome. There's also another system. I've been playing back and forth emails with the company, but Haven IAQ, TrueTech Tools is selling them. it's a little remote probe that you can put into the return side of an air handler, and it'll do things like particulate, CO2, VOCs. It can, I'm not sure if it can yet, but they're working on, getting like pitot flow rates or what is it, like hot wire anemometer features and stuff like that. So you can watch static pressures and flow rates inside of air handler units remotely, and they can be set to ping the installers or the service technicians when they're seeing issues, or you can just monitor it and see what's going on. So like microelectronics revolution, like you said, it's coming. Eventually, I hope to see that we'll have like IAQ monitors and hygrothermal monitors, and the HVAC system and everything will integrate and talk to one another, which I'm sure will be a nightmare of programming for a couple of years, but eventually we'll figure it out.
Yeah, that's a shout out to Phil and Chris. That's the 6-digit idea, right? Or maybe the 7-digit idea in this case, to go ahead and integrate the sensors with the thermostat computer. Even if it is obscenely expensive on the front end, it'll eventually come down. And then you basically have already there?
They're not there. They're working on it, though, from some conversations I've had.
But not just for the HVAC system, but quite literally the wafer sensors like Code is using in walls, monitoring the underside.
Yeah, I don't know. I don't know about that, but yeah, like the interior ambient conditions, and then watching exterior ambient conditions and anticipating changes that are coming to adjust, and watching things like range hoods and bath fans and humidity levels and stuff like that, so that it all communicates together and you have more granular control over the interior environment.
All right, BS and beer viewers, start saving your money. Ben says it's coming. One less beer this week. I'm saving that. That $6 is going straight into that logging system.
And by the way, I think both Ben and Doug mentioned indoor air quality monitors, and I'm also a huge fan. I personally use an Aware. Who knows which one the best one is? I've not done a side-by-side comparison, but you get so much information about what I use them on my own house, and the big lesson was, holy crap, particulates go crazy whenever I do any cooking. Just they spike all over the place, even with a range hood running. However, turning on the furnace fan just to run stuff through the MERV 13 does help stuff out. Also, an interesting point is that your VOC sensor on your indoor air quality goes crazy when you open up a bottle of scotch.
That actually...
Yeah, and you want to tell, like, it's okay, I'm putting these VOCs in my body.
Yes, they'll be used for good instead of evil. Actually, that brings up a question I have. I know two people who are having really high CO2 level readings in their house, and basically there's no obvious cause. The houses are one's reasonably leaky, one's reasonably tight, but has good mechanical ventilation. They have wood stoves, but they have makeup air, and they don't use them a lot. We can't find any source. Actually, Peter Yost is looking at one of them soon, because we can't figure it out. Any experience with high, like 1500 ppm CO2 levels with no obvious cause?
I'm assuming that they've isolated things like it's not just occupancy, or occupancy in a small room or anything like that, right?
This is relatively secondhand, or one of them is it's been ongoing for quite a while. There's two adults and a baby in a medium-sized house, so it's been consistent over time that it's hovering around 1500 ppm, which is like twice what it ought to be. And it seems to be high if the wood stove is running or not on that one. The other one is an older couple with a tied house. They have 2 Lunos systems plus a Lunos Ego in the bathroom. So Mike Duclos did it. So, or like, I'm sure it's done well. It's just they can't get it below 1500 either.
Man,
one who's raised a small child and had the stupid diaper genie knows that your indoor air quality is not good until the kid is out of diapers.
The diaper. Okay, that is a good clue.
Diapers and mouth breathing.
Yes.
I think Drew Gillette's right. No, sorry, go ahead.
Oh yeah, just I think the older folks I don't think are at diaper level yet. So I think that might explain the one with the babies, but I don't think it will fit the older couple. But
yet.
Yeah.
I think Drew might be right to check the accuracy on the instruments, which usually they reset themselves to 400 at the low point in a given week. So they shouldn't stay at 1500 unless there's a real issue.
Okay. Yeah. I forget. I think the couple with the baby, I think they have a food bot. They're actually friends with Emily too. And she likes the Foobot. So,
Foobot?
Or no, Yoo-Hoo is the one.
Okay.
Yeah.
Yeah, Foobot doesn't have an actual CO2 sensor. Their software used to give a CO2 reading, but it was based on humidity, basically.
Oh, interesting.
Yeah.
Well, that actually I should
right,
confirm that. So Foobot is based on humidity.
Yeah, it's like an algorithm that assumed that a rise in humidity and VOCs was due to occupancy and would guesstimate what your CO2 would be if it was actually sensing it.
Interesting.
Yeah.
Yeah, I didn't know it was humidity tied. I thought it was VOC tied, but yeah, I know that it's
No,
not.
I could be wrong about that. That's what
Yeah, I could be totally wrong too. I haven't been able to find out any good info on that, but yeah, it's not a true CO2 reading. That being
Well, we're
said, when you
to the end of the show. I don't want to interrupt you, Ben, but we are we're dwindling down to the end. And after Mike's adult diaper joke caused a terrible coughing fit in me, I missed what you just said. So if I interrupted you, I apologize. But we are nearing the end of the show, and we usually kind of go around the horn for final thoughts. If anyone has any recommendations or things that you didn't get to touch on that you really are just burning to share with the world, this is a great opportunity to do that before we log off.
I'll go first. I just want to say I turned my holiday lights back on after last week's awesome presentation on lighting, and when they said that was perfectly fine if it makes you feel good. So I hope everyone else enjoyed that.
I'm so pleased that your circadian rhythms have been restored, Doug. Thank goodness.
What do you have, Ben? Last thoughts. What should we all be measuring?
As much as you possibly can stand to.
And get other people to pay for, right?
Yeah, hopefully. That's the ultimate goal.
I've been meaning to ask about like the built-in cost here, but we've run out of time. I'm kind of curious about that.
I'll give you rough numbers. For me, it's ranging anywhere from $600 to $1,500, depending on how crazy I go.
Mm-hmm.
IAQ is a totally different story. I'm investigating that right now, which is easily, for good quality sensors, I'm looking close to 10 grand.
And is that something that the clients absorb, or I mean, how does that work?
No, I can't speak to how Dan built it out, but I don't think we ever build it to clients. And the company I'm with right now, it comes out of our profit.
Mm-hmm.
So it's strictly, research purposes for our own usage.
Yeah,
bring it home, Coda. What do you have? Or go ahead, Doug.
No, you go ahead, Coda.
Just a general thing. More data is good, but always make sure that there's somebody who will look at it, because data without collected with nobody ever looks at it is kind of a waste.
Mm.
Make sure there's budget or something, resources.
Right.
Good tips. Thank you, guys.
Thanks for the great presentations. That does it for tonight's show. We'll see you next Thursday. And a sincere thanks to Coda, Ben, and Doug for sharing their time. We really appreciate it. And thanks to the audience for joining us. Have a great night.
Night all.
Thanks, guys.